I'd like to introduce myself as Ben Hunt. I'm one of the graduate engineers here at WMG. So today I want to explain a little bit about what electric machines are. So I'll cover what they are, where you'll find them, and then give you an idea on what role they have in combating climate change. So first of all, a bit about me. I grew up in the northeast of England in a place called Darlington, and then I moved at the age of 19 to study material science and engineering at the University of Manchester. And then once I graduated there, I then moved straight to Coventry to work here at WMG. Now, I currently work in energy innovation, and that can pertain to a lot of things, but to name a few, it essentially looks at anything from battery solutions for energy storage, or generation or transmission. So, for example, the new battery chemistries that Trainee was explaining before, or the power electronics for electric vehicles, or what I want to talk about today, which is electric machines. Because these innovations, they are crucial if the world is to reduce greenhouse gas emissions and combat climate change. So they are crucial if the world is to move to a more electrified future. So what are electric machines? Well, you might not have seen these images before, and you'll probably just recognize the one on the far left as an old-fashioned experiment, and you would be right. These were created by a famous English scientist named Michael Faraday, and they were one of the first examples of an electric motor. So the drawings on the right sort of explain how they work. So essentially, electricity or electrons run through a conductive wire, and this creates a magnetic field perpendicular to the floor. So this can be seen in the second image. So for Faraday's experiment, seen more clearly in the far right image, this wire sat in a conductive liquid, which is then connected back to the battery, and then this completes that electrical circuit. So then the electrons are allowed to flow. So the magnetic field created around the wire interacts with the magnetic field from that fixed magnet in the bottom of the glass. And it's this interaction that forces that wire round in a direction perpendicular to both the magnetic field and the current flow. And that can be illustrated by the black arrow. Now, although they don't have much practical use, they did help us to explain the concepts of electromagnetism. And years later, Faraday used this exact same concept, but by applying a force or a motion to move that magnet through some fixed wire, and then this created a voltage which pushed all them electrons back into the battery. Again, the experiment seems little use, but if we fast forward 200 years, these images may look more familiar to you. These are the real world examples of electric machines. So their function is defined by the previous two principles I've just explained. So it's present in the motors. So that's in a washing machine, for example, or generators. So these are the source of most electricity generated in the whole world. So if you describe them fundamentally, you're converting kinetic energy or mechanical energy into electricity, in the case of them turbines, and back again for a washing machine. So you might think, why do I care? Well, as mentioned earlier, we need these electric machines if we move to a greener future. So for generators, that means no more burning fossil fuels to generate that mechanical energy, but instead relying on renewable sources such as wind or hydropower. And for your motors, this means that we no longer can rely on igniting that diesel or petrol in our current combustion engines to generate motion, but instead we should use the electricity stored up in batteries, which will then drive the motor. Now, you might not think there's a problem here. So for example, to quickly get more electric vehicles on the road, we could just rapidly produce more motors and be done with it, but that isn't quite the full story. So one problem is good electric motors, they can be very expensive. So although I haven't covered it here, there are many, many different types of electric motors, and each have different benefits over the other. For example, permanent magnet motors, they're typically used in electric machines, electric vehicles, and these work in a similar principle as explained before, where that permanent magnet, which is attached to the rotor or the rotating part, and that interacts with the magnetic field created by the current in the coils on the stator, the stationary part. And the stronger that magnet used, the more force turns the motor, which will then spin the wheels. So you get more force per kilogram of motor. So this is particularly important for, say, electric vehicles, where you really want to reduce that weight to go further. But unfortunately, the strongest permanent magnets are derived from rare earth metals. So as the name would suggest, these are quite rare. Hence, the sudden demand for them means that their cost increases, and so do electric vehicles, which isn't good for us consumers. And the same is true for power generation. The stronger the permanent magnets, the more energy can be captured per turn of a wind turbine. Hence, the increase in rare earth metals means an expensive electricity. So that's not good when the fossil fuels are cheaper than renewables. So what's the solution? Well, we could stop using permanent magnets. However, that would mean that the motors driving an electric vehicle would be less powerful and efficient. So whereas this is still feasible, but at a time where we're trying to squeeze every bit of energy out of the battery, maybe there are other solutions. So one solution we could look at is if we are still to use permanent magnets, maybe we can reduce the cost elsewhere. And a more dull method is to explore new manufacturing processes to reduce waste and cost. So for example, the stator, that stationary part, is made from electrical steel laminations, as opposed to just a giant block of steel. And this is to improve its efficiency. But these are usually stamped from giant steel sheets. But by stamping a little strip and bending it into what looks like a slinky on the far right, means less steel is wasted. So that means we can be more inventive with the types of rotors we use. So this is important for sustainability, especially as our reliance and demand for electric motors increase. Another solution, we could create new materials. For example, electrical steels are being explored to increase the electrical efficiency of the motors, so like new grades of electrical steel. So if any of you have seen Russ's lecture about our reliance on steel, well, to use a quote from him, and it's worth a watch, using next generation grades of electrical steel in our current electrical machines would be so much more efficient, they would save enough power to turn off 12 nuclear power stations in the UK alone. So this age-old material is still very relevant now. Another thing that we could look at is using alternative materials. So for example, on the motor you see on the right, the conductive coils, we could change them from traditionally used copper to aluminium. So I'm sure you've heard of them elements before. And aluminium is particularly light. So this would decrease the weight of a motor, this would decrease the weight of them coils by almost a third. And in addition, this aluminium is significantly cheaper, almost 3 times as cheap. So though there are manufacturing issues with the aluminium, you know, it's very soft and trickier to wind into them coils. So this would need to be resolved first, but this replacement would make electric machines much cheaper, which is what we want. And another one is to potentially explore the uses of new materials like composites, such as carbon fiber. These are very stiff and light materials, so using it in automotive industry makes sense. So for example, in the motors, this could be used to constrain that large spinning motor, and it would help improve a motor efficiency, and it means it could spin faster, so hence you could go faster. So these are a few different ideas. There's a lot more out there, but what does this future look like? Well, we're currently at that fork in the road. You know, we could continue as we are, slowly electrifying our fossil fuel dependent industries, but this slow uptake would mean electricity prices are higher for longer, and the air that we breathe will be polluted for longer. So it means that this global warming will pass the irreversible tipping point, which hasn't happened for the past 10,000 years. Or we could just start innovating now. But not only that, we could begin to move these lab scale innovations and work alongside industry to implement them at a much faster rate. So taking this action would mean that all the government and global pledges to reduce carbon emissions will actually be feasible. And this is the work that we do here at WMG. And this year, the UK is taking presidency of the UN Climate Conference, COP26. So there's never been a better opportunity for us to work together to a more electrified and green future. Because remember, global warming will affect us all.